Tonight, we dive into the subject of a single molecule, nitric oxide, one that is so important that the Nobel Prize in Physiology or Medicine was awarded to 3 people involved in its discovery. So important that it helps relax your blood vessels so blood can flow more easily throughout your body. So important that your cardiovascular health, especially as we age, is predicated on how much our bodies can produce. Tonight, we are joined by someone who's dedicated much of his professional life researching and understanding the importance of nitric oxide, and that is Dr. Nathan Bryan. Good evening, everyone. I'm Jim Spellos from Plant-Powered Metro New York, and along with my co-hosts Judith Zerden and Ben Martins, we welcome you to this episode of Heart to Healthy Heart. As always, we encourage you to use the chat box to tell us where you're viewing from, as well as to ask any questions of our special guest. And as always, we'll try to get to as many questions as possible as a 30-minute time slot that can allow. Let me add Dr. Bryan to the screen and say a good evening to him. And while I do, also do a quick introduction of him so we can start it off. Dr. Nathan Bryan earned his undergraduate Bachelor of Science degree in biochemistry from the University of Texas at Austin and his doctoral degree from Louisiana State University of LSU School of Medicine in Shreveport, where he was the recipient of the Dean's Award for Excellence in Research. He pursued his postdoctoral training in the Kirsten Fellow at Boston University School of Medicine in the Whitaker Cardiovascular Institute. And after a 2-year postdoctoral fellowship in 2006, he was recruited to join the faculty at the University of Texas Health Science Center at Houston by Dr. Farid Morad, who was one of those Nobel laureates. He's been involved in nitric oxide research for the past 20 years and has made several discoveries in the field. Dr. Bryan, thank you so much for being here tonight. And let me also invite on our other co-hosts so we can all get the chance to get to meet you. So again, thank you so much for being here, sir.
Well, thank you very much. It's an honor and pleasure.
We're going to start off with the softball question, which is what we always do here. And that is, what's nitric oxide and why is it so important for everybody to know?
Well, it is a very important molecule. In fact, it's one of the most important molecules produced in the human body. In fact, most mammals. But it's how cells in the body communicate with one another. And it's mostly recognized as a vasodilator, meaning that when it's produced, it opens up all the blood vessels and so you get better blood flow and oxygen delivery. It inhibits inflammation, oxidative stress, and immune dysfunction, the main hallmarks of every chronic disease. It's a neurotransmitter in the central nervous system, so it's involved in long-term memory potentiation, signaling between synapses. And it's also how our immune system fights off pathogens, from viruses to bacteria. So now you can appreciate the host of things or symptoms that go wrong when you can't make nitric oxide. It's not, as we thought, 30 years ago, you just develop high blood pressure and erectile dysfunction. A number of things go wrong.
Fascinating. Judy?
So good evening, Dr. Bryan. So I understand that there are different pathways for nitric oxide to be produced. Are there 2 distinct pathways or are there more?
Well, today we know that there's 2 primary pathways. And it's not to say there's some pathways that we haven't yet discovered or stumbled upon, but now we understand mechanistically and biochemically how the body makes nitric oxide. So the first pathway to be discovered was through the discovery of an enzyme called nitric oxide synthase. And this started back in the early 80s, and then it was fully elucidated back late 80s, early 90s. But this enzyme called nitric oxide synthase, it's found in our endothelial cells, it's found in neurons, and it's found in our immune cells. This enzyme is tasked with converting arginine into nitric oxide gas. And this is a very complex reaction. It's energetically and kinetically unfavorable. 5-electron oxidation. It's really some complex biochemistry. And it's that pathway, it's that enzyme that becomes dysfunctional with age. So now we understand that we lose about 10 to 12% of the function of that enzyme per decade. So by the time we're 40 or 50 years old, we have 50% of the nitric oxide being produced from that enzyme. So now we understand that doesn't necessarily have to be the case. We can prevent the uncoupling and the age-related loss and function of that enzyme. But we also understand now, probably from 20 years ago, that the body can make nitric oxide from diet. And I think that now explains many of the health benefits and the cardioprotective benefits of a plant-based diet, the Japanese diet, the dietary approaches to stop hypertension, because certain dietary patterns and food choices enrich the human body with nitrate that then the body can then convert into nitrite and nitric oxide gas that's vasoactive and can recapitulate nitric oxide-based signal. So those are the two primary pathways that we fully understand mechanistically and how we can basically hijack those and improve the function from both pathways.
So to dive into the second pathway, diet, are there certain plant foods that we can eat to maximize nitric oxide production?
Well, yes. I mean, broadly speaking, it's the green leafy vegetables. And typically, the darker the green vegetables, the higher the nitrate content. And that's just from nitrogen assimilation. But, we tried to answer that question back in 2014 and 2015, where the question was, and kind of our charge was, if we wanted to, because we knew how much nitrate you needed in a single meal to be metabolized into nitric oxide to normalize blood pressure and to improve blood flow and exercise performance. So the question was, how much celery, broccoli, spinach, or lettuce or kale would you need to eat to achieve that threshold of nitrate to improve blood flow and nitric oxide production? And the answer was not that surprising, but the degree of the variability of the nitrate content in vegetables from different geographical regions. So we went to Chicago, Dallas, Los Angeles, Raleigh, and New York. And we found that the nitrate content in the same vegetable, there's as much as a 50 to 80 fold difference in the nitrate in celery in Dallas or Los Angeles compared to New York. So now we understand this whole field of agronomy on how vegetables are grown, where they're grown, the soil conditions, if you add nitrogen-based fertilizers, that all determines and dictates the amount of nitrate in the vegetables, but also the assimilation of other micronutrients. So there's really, if we're speaking broadly, the darker the green leafy vegetables, typically on average is going to have the higher nitrate content.
Yeah, so you anticipated my next question, but actually I've heard you say that in addition to that because of the way organic produce is grown in the United States, that people who are trying to, eat a whole food plant-based diet or eat a lot of plants without that, and are looking to minimize their pesticide consumption and are eating organic, that they can't get enough nitrate from eating those vegetables to make a difference. Is that true? Because that really made me feel pretty defeated.
Well, that's always the jaw-dropping moment when we published that in our 2015 finding, because we wanted to compare conventionally grown vegetables versus organically grown vegetables. But let's just step back. Aside from our study in 2015, we've known since 1940s that the nutrient density of all vegetables grown in the U.S. has declined by as much as 80% from the 1940s to the early 2000s. So this pressure to feed a growing population is at the expense of nutrient density. We don't do crop rotation anymore, and there's this whole movement toward organic, and I think rightfully so, because we don't want to be putting herbicides or pesticides or dangerous toxic chemicals in our body with the food we eat. So we have to figure out how to do this. But as you mentioned, to get an organic label in the U.S., it's not only the exclusion of herbicides and pesticides, but there's also a restriction on standardized nitrogen added to the soil of organically grown vegetables. So nitrogen is one of these essential nutrients that's needed to assimilate other micronutrients and trace minerals and vitamins. So, and we can add like compost matter, manure, but again, there's no standardization of the nitrogen in that. So the variability is much higher. So I'm a fan of organic, in fact, that you don't getting these toxic chemicals, but we have to come to a healthy medium here where we have to begin to do soil sampling, figure out what's missing from the soil, and then replete that back. So now that the vegetables we're growing actually can be replete in a lot of the minerals that we're deficient in.
Good evening, Dr. Bryan. Which foods deplete nitric oxide production?
Well, it's the things that are known to cause, increased risk of cardiovascular disease. It's the highly processed, high sugar products. We're over consumers of sugar. This leads to glycation of many proteins and enzymes, including the NOS enzymes. The other is highly processed, food with a lot of additives and preservatives in there. Again, these are chemicals typically the human body hasn't seen when we eat from nature. And so a lot of that leads to oxidative stress, which leads to oxidation of BH4, which uncouples the NOS enzyme. And then the other thing is, so we understand mechanistically what goes wrong in the NOS pathway. The other thing, when we consume a lot of simple carbohydrates and sugars, that completely changes the oral microbiome. So now you get this upregulation of a lot of caries-causing bacteria, downregulation of a lot of these facultative anaerobes that are nitrate reducers. Because if you give these bacteria, and what we study are the facultative anaerobes, they can respire on oxygen, they can respire on carbon, they can respire on nitrogen. So if you don't give them nitrogen in the form of nitrate, then they're latent. If you feed them a lot of sugar, then you get a lot of bad guys. And so what we're finding is that the greater the diversity in the oral microbiome, the healthier the oral microbiome, and you get better oral health, better nitric oxide production.
How does a deficiency of nitric oxide affect our health?
Well, a deficiency, so I think there's a spectrum of deficiencies. And what we've learned is that the first sign and symptom of nitric oxide deficiency is an increase in blood pressure. So when you lose the production of the main vasodilatory molecule, nitric oxide, your blood vessels start to constrict. You get the same volume pumping through a smaller pipe, your blood pressure goes up. So and 2 out of 3 Americans have an unsafe elevation in blood pressure. The other, one of the first signs and symptoms is erectile dysfunction. And there's a reason that's called the canary in the coal mine. Mm-hmm. So if you can't make nitric oxide in the sex organs to dilate the blood vessels to get engorgement in both men and women, by the way, then you develop erectile dysfunction. And so if you have endothelial dysfunction, and if you can't make nitric oxide in the vascular bed of the sex organs, then you can't make nitric oxide in the blood vessels of the heart, the brain, the liver. So this is a systemic problem. It's a systemic disease. And that's why erectile dysfunction is a sign and symptom of a nitric oxide deficiency that, if not corrected, will put you on a very fast track to cardiovascular disease, heart attack, and stroke.
What is an endothelium?
The endothelium is the single layer of blood vessels single layer of cells that line all blood vessels throughout the body. And so it's the endothelial cells that really maintain the integrity of keeping the immune cells in the lining of the blood vessels or outside the lining of the blood vessels, and then allows for this barrier function. And different tissues, like the liver, have what's called fenestrated endothelial cells. The blood-brain barrier has very tight endothelial cells. So the vascular bed of individual organs, the endothelial cells have different functions. But the primary function of all endothelial cells, no matter if it's in the brain, the liver, the heart, kidney, is to maintain nitric oxide production so you can regulate blood flow and blood pressure upon demand. But it also prevents the adhesion of molecules like monocytes and neutrophils. So you downregulate the adhesion molecules, and you prevent the vascular inflammation that occurs from whether it's a poor diet or exposure to toxins.
Jude?
Okay, I thought Ben was going to ask another question. Ben, do you want to ask about?
Yeah. How does endothelial dysfunction lead to cardiovascular disease and other chronic inflammatory diseases?
So the function, there's the endothelial cells perform lots of functions, right? But what we focus on, and one of the main functions as it relates to cardiovascular disease, is the production of nitric oxide. So when we develop endothelial dysfunction, and now that's characterized or diagnosed by the inability to produce nitric oxide. So now it's hard to divorce endothelial dysfunction with decreased or inability to produce nitric oxide. So when we lose the ability to produce nitric oxide, now those particular vascular beds, let's look in the heart, for example, can't make nitric oxide. So when we start to exercise, the normal response would be that the coronary arteries need to increase their diameter to get increased blood flow to the heart to meet the increased metabolic demands on the heart. So if we can't make nitric oxide, then the coronary arteries can't dilate, and then we develop ischemic pain known as angina. And then if that's not corrected, then these blood vessels start to get the plaque deposited in them. The plaque becomes unstable, and the plaque ruptures, and then you have a heart attack. So everything we know about the progression of cardiovascular disease, from the initial microvascular inflammation to the plaque deposition, plaque instability, and plaque rupture, is determined by nitric oxide. If the blood vessels can make sufficient nitric oxide, then you're going to get vasodilation, you're going to increase blood flow, you're going to prevent the inflammation, you're going to prevent the plaque deposition. So then there's no plaque, there's no unstable plaque, there's no plaque rupture, there's no heart attack or stroke.
Okay, so now I will ask. So we touched a little bit on the oral microbiome, and I know a lot of people have been focusing lately on the gut microbiome, and a lot of people just use things like fluoride in their mouthwash, fluoride in their toothpaste, fluoride in their drinking water, and they have no idea that they're doing anything wrong. In fact, they're thinking that they're killing bacteria and helping themselves. So what would you say to that?
Well, I think the evidence is very clear now. And, there's fluoride is one of the most toxic elements in the periodic table. I mean, it's a neurotoxin, it's an antiseptic, and it destroys your thyroid function. So to me, it's not a mystery why we have a pandemic of hypothyroidism. Fluoride, as you mentioned, it's in toothpaste, it's in municipal water, it's in a lot of mouth rinses. And it does what it says it does. It's going to eliminate 99.99% of the bacteria in and on your body. Well, the bacteria that live in and on our body outnumber on human cells 10 to 1. You eradicate the bacteria that live in and on your body to your own demise. So we have to maintain a healthy microbiome. So fluoride, if you use fluoride toothpaste, it's an antiseptic. It does what it's advertised to do. It's going to kill the bacteria, the good, the bad, and that's very dangerous. So what happens if you destroy the oral microbiome? Your blood pressure goes up. We reported several years ago, you lose the protective benefits of exercise. You lose the cardioprotective benefits of a plant-based diet. So people are doing, and the best example is you try to eat right, you try to exercise, you do all the things that we're thinking we're doing to help the body. But if you're using mouthwash or fluoride, you completely eliminate the benefits of all that. So now we have to recognize that if you use mouthwash, you got to stop. If you're exposed to fluoride, you have to get rid of that. Use a fluoride-free toothpaste. Get a home filtration water system to eliminate the fluoride in your water supply, because it's not just the water you're drinking, it's the water you're bathing in, cooking in, drinking. And fluoride is a very toxic chemical.
Let me jump in here right now because we have a question about that from the audience, and they're just asking about the drinking water. If it's fluorinated, can you get any nitric oxide at all?
Well, yeah, provided that you have a functional nitric oxide synthase enzyme, because remember, we have two ways that make nitric oxide. If one is disrupted, then we have to rely on the other, so that one can compensate for the other. But you have to make sure that you have good endothelial function, because if you're using fluoride, you're killing the oral microbiome, then you've completely shut down nitric oxide, 50% of the body's production of nitric oxide. So now your only nitric oxide is going to come from the enos and the function of that enzyme. So now we have to make sure that you have good endothelial function, that you're making nitric oxide in the lining of the blood vessels that can compensate for the loss of nitric oxide from the oral microbiome.
Great. Okay. So yeah. So my next question that I wanted to ask you about is proton pump inhibitors and over-the-counter antacids such as Prevacid or even Pepto-Bismol. Is that an antacid? I just wanted you to explain how those interfere with the production of nitric oxide.
Yeah, look, these are very, very dangerous class of drugs that we've experienced over the past and really investigated over the past 10, 15 years. So first of all, these class of drugs are called PPIs, or proton pump inhibitors. And any drug that inhibits stomach acid production is really a bad idea. I'm a physiologist and biochemist by training, and inhibiting stomach acid production is probably the worst thing you can do for the human body. You can't digest proteins into amino acids. You get peptide fragments absorbed across the gut. You develop autoimmune disease. You develop foodborne allergies, all because your body can't make stomach acid production. But specifically proton pump inhibitors. So let me step back a little bit, just mechanistically. So when we eat nitrate and we have the right nitrate-reducing bacteria, that produces nitrite in our saliva. So now when we swallow nitrite becomes protonated at pH 3.6, and that generates nitric oxide gas. So we have to have stomach acid to get nitric oxide produced in the lumen of the stomach. So if you're taking antacids, you alkalize the lumen of the stomach, so you don't get any nitric oxide being produced. but specifically the proton pump inhibitors, things like omeprazole, Prilosec, Prevacid, they inhibit an enzyme called DDAH. And the consequences of that is you get an increase in a metabolite called ADMA, or asymmetric dimethylarginine. Now that inhibits the enzyme that makes nitric oxide in the lining of the blood vessel. So now these proton pump inhibitors, or antacids, are shutting down nitric oxide production from both pathways. What are the consequences of that? In 2016, it was published that people who had been on PPIs for 3 to 5 years had 40% higher incidence of heart attack and stroke. Oh. So these drugs were never approved by the FDA, by the way, for long-term use. They were only approved for acute treatment for gastroesophageal reflux disease. But now you've got people who are prescribed these. There's 200 million prescriptions written for antacids every year. That's not even counting the over-the-counter. You can go now and take Prilosec, Prevacid, OTC every day, every year for 10, 15, 20 years. And the consequences are deadly. People are dying from heart attack and stroke because it's shutting down nitric oxide production.
Yeah.
Doctor, does the nitric oxide synthase decrease as we age?
Well, there's two things we consider. There's the expression, so the genetic transcription or translation of that genetic code into functional protein or enzyme. So the older we get, the less expression we have, and there's certain things that decrease the expression of that in cells. But more importantly, we look at the functional aspects of it. But it's really the function of the enzyme that decreases with age. So we understand this through this 5-electron multi-step oxidation, the rate-limiting step in nitric oxide production, and it's the oxidation of tetrahydrobiopterin. And so when that becomes oxidized, the enzyme uncouples, and now it starts to generate superoxide instead of nitric oxide. So it's really the function of the enzyme that decreases with age, and that's all relegated by usually diet and lifestyle.
Can eating an anti-inflammatory diet and other lifestyle factors compensate for this decrease?
Absolutely. So we just got to mitigate the oxidative stress. And in biochemistry, we look at what's called a redox potential, or it's a voltage or an electrical potential that's needed to extract an electron from a molecule, right? And there's certain redox potentials that lead to oxidation of certain biomolecules. So we know what that redox potential is to prevent BH4 oxidation. You can do it through an anti-inflammatory diet and just giving enough antioxidants to prevent the oxidation of these biomolecules, then you can maintain normal NOS function.
Other than diet, how else can we increase nitric oxide production and absorption?
Well, we can moderate physical exercise. You know, the chemistry of and the science of nitric oxide is very complex and complicated, but the solutions are pretty simple and basically what we've known for centuries. A diet, a good anti-inflammatory diet, moderate physical exercise stimulates nitric oxide production. 20 to 30 minutes of sunlight exposure a day. Sunlight, certain wavelengths of light can release nitric oxide down to metals and stimulate nitric oxide production. So I tell people, if just to increase nitric oxide, do two things. Stop doing the things that disrupt it and start doing the things that promote it. And that's what we like to advocate. Use diet and lifestyle and common sense, science-based strategies to restore nitric oxide.
Intermittent fasting.
Let me jump in with a question that's really a follow-up from the audience about this, which is regarding the cardio and the weight training. Is there a balance that you need to have in terms of how you exercise to maximize this?
Well, you need oxygen to make nitric oxide. So when you run out of oxygen, you're going to run out of nitric oxide. So I tell people you don't have to go into, push your anaerobic threshold, just 20 to 30 minutes of a light aerobic exercise. I do 20, 30 minutes of cardio every day, and then I'll typically go do resistance training. Because with resistance weight training, you're creating what's called brief periods of intermittent hypoxia. So when you contract the muscle, you're contracting the blood vessel and creating intermittent hypoxia. Then the adaptive effects of that is like your body's saying, oh, I need to generate more blood vessels, create more nitric oxide so I don't experience that brief periods of hypoxia. So it's an adaptive effect. So I like both. Look, I think you need resistance training to prevent, osteoporosis and osteopenia and prevent muscle loss with age. So it's a balance.
Intermittent fasting or caloric restriction, does that impact the production?
Well, so intermittent fasting and caloric restriction have shown to induce what's called PGC1 alpha and mitochondrial biogenesis. So these are the adaptive effects or hormesis on that. But both of these, intermittent fasting and caloric restriction, are dependent upon the body's ability to make nitric oxide to induce that pathway. So if you have endothelial dysfunction and the NOS enzyme is uncoupled, then you can do caloric restriction, you can do intermittent fasting, but you're never going to get the metabolic end products of that, of mitochondrial biogenesis and improved mitochondrial function, until you restore the production of nitric oxide. So I just want to say nitric oxide is really foundational for everything we know about longevity and health and wellness. And it's not the end-all, be-all, cure-all, but in order to induce these other kind of proven strategies, you need to make sure that the function of the NOS enzyme is such that you can potentiate these signaling pathways.
So a member of the audience asked, is there a way to test for nitric oxide?
Yeah, just, I guess 15 years ago, I developed a salivary test strip, and I've kind of gotten away from that because it's a way to test your saliva, and what we're measuring is salivary nitrite, the ability of your oral microbiome to reduce the nitrate in your diet into nitrite. So I tell people it's a good tool to have in your toolbox, but it shouldn't be the only tool you're using because there are a lot of false positives. The best example is patients with active oral infections. They'll be systemically nitric oxide depleted, but they'll light up the test strip. So I really rely on symptoms. And so if you have a blood pressure of greater than 120/80, you're starting to decline in nitric oxide production. If you have insulin resistance, that's a sign of nitric oxide deficiency. Any degree of erectile dysfunction in men or women is a symptom of nitric oxide deficiency. If you're developing mild cognitive disorders and can't remember where you left your keys or losing your memory, then that's a nitric oxide deficiency problem.
We have time for one more question from the audience, and I know Judy has one last question, but from the audience, does the corticosteroid hormone inhaler disrupt nitric oxide production?
Well, it can. Steroids by definition decrease the expression of certain proteins, and so they also, decrease the activity of your immune system. So, in terms of nitric oxide itself, I'm not sure if there's a direct connection, but certainly indirectly, what we have to do is, basically restore the function of the enzyme. And so I think acutely what we're doing to fix, and a lot of medicines are good for acute fixes. But when you do this every day, you're downregulating the genetic expression of a lot of these protective molecules. And eventually, I think it's going to lead to a loss of nitric oxide, not only expression, but probably a disruption in the function.
Judy?
Okay. Yeah, I just wanted to follow up on the conundrum we were talking about before about the organic vegetables, because most of us don't have the ability to test the soil and to understand whether the organic vegetables that they're paying all this money for are, have any value in terms of nitric oxide. And that's one of the main, reasons that a lot of us are, making this the focus of our diets.
Sure.
What do we do? Are there things that we can do to enhance it? Should we do like Esselstyn says, like add balsamic vinegar and,
Well, Dr. Esselstyn, he's a very wonderful guy and a good friend. I've become good friends with him over the years. But yeah, the balsamic vinegar basically acidifies the lumen of the stomach. So it's not really affecting the nitrate or the nutrient density of the vegetable. It's helping you digest that and breaking down the proteins into amino acids and basically facilitating nitrite production of nitric oxide. So I don't, I tell people to buy local, know your local growers, know your local farmers market, and have conversations with them and see what they're doing. But typically what you'll find is that if you've got vegetables that are really dark green, then I think that's a reflection of sufficient nitrate. If you've got, and you can look at, fertilize, and, we grow our own vegetables where I live on 800 acres and we raise our own beef. We grow our own vegetables, but, I add nitrogen to the soil. I do soil samples and I know what's missing and then I replete it back, but I certainly don't add any herbicides or pesticides. So I think it's a balance, and I just tell people to shop local, go to your local farmers market, have conversations with them, and then figure out how to optimize this.
Thank you.
Amazing half hour. Time's already up, and it's really incredible. It went that fast. Dr. Bryan, I want to thank you so much on behalf of Judy, Ben, and myself for being here. I want to let people know if you want to find out more about Dr. Bryan, go to his website, drnathansbryan.com. Any other ways they can reach out to you as well, other than the website?
The website, that's my Instagram handle. You can follow me. I've got a YouTube channel and LinkedIn. So that's typically, I send people just to my education sites to hopefully they can get informed and educated on nitric oxide.
Fantastic, on all the socials. By the way, the next Heart to Healthy Heart will be in September. We're taking August off, and we're coming back sometime in September. Do stay tuned to our YouTube channel and Facebook page for that. So if you want to watch any of our episodes again, please, you can go to the Plant Powered Metro New York YouTube channel. And on behalf of Judy and Ben, I'm Jim Spellos, wishing you, as always, optimal health, and looking forward to seeing you in September. Like, that was a song, wasn't it? Oh, that's right, on Heart to Healthy Heart. So thanks again. See you soon.
Thank you.